Hello, everyone. Let's explain a little bit better the Miller indices so we are understanding them well. First of all, as we discussed previously, consider all sides of the crystal lattice as equal to 1, to unity. This will simplify our procedure significantly. Of course, as we said, like in this situation, we have the cubic lattice, and you can see that if we consider along the x-axis instead of 4 Armstrong or so along the y-axis or 8 axis as being 8 Armstrong, and consider everything 1, that's simple from the beginning. We simplify our problem. So for the direction indices, we do have vectors. This is what we are after, that direction, and the vector defines the Miller indices define the direction of the vector. So we for a vector we have a head and a tail, and the first thing is when we are started, we need to basically find the coordinates of the head and coordinates of the tail. Of course, we do have an origin. Most of the time, this is where we select the coordinate frame like usual. So you can see here that we have 1, 0, 1. On the x-axis, the head basically here, it's this one, 1. There is nothing on the 0 and the y-axis, and on the z-axis, it sits on 1 also. For the tail, we can see that the tail sits on we don't move along the x-axis to get to the tail, and we also don't move along the z-axis to get to the tail. We only move 1/2 in this direction to get to the tail. So those are the coordinates 0, 1/2, and 0. And in our table, the next step, it will be to subtract the head coordinates minus the difference, minus the tail coordinates, and we get these values. Then we can see that we end up with fractions. So that means we have to reduce the fractions, and you can see that the common denominator is 2. We amplify with 2, and we get Miller indices as being in the, again, the square brackets, not parentheses. So we have 2, 1 bar, that's -1, gets as a bar atop the 1. So we call them 2, 1 bar, 2. Those are the Miller indices. Now, if we have, suppose we have the inverse problem, we are given the Miller indices, in this case, like we had 2, 1 bar, 2, and we want to draw, we are asked to draw the direction. This is a procedure. First of all, we realize we have a common factor, because here, of course, we can, instead of pulling the common factor out and selecting the tail, based on this 2, we see that we need to move on the x direction with 2 units. That means we are out of the crystal lattice, because we said the crystal lattice has a unit, a length, a side of 1. So we have to move in the next one. And that means it requires more drawing on us and so on. So to keep our everything in one crystal lattice, we follow this procedure, which means that, first of all, if we have to, like in this case, we have a common factor because everything is beyond 1, beyond unity. So we have that, we pull that common factor out, and in front of the parentheses, which is basically the magnitude of the vector, and the direction of the vector is in here. As you can see, we have, after we pull it out, it's the inverse problem, basically. That's what we are doing in this case. And then we see that we have a negative value here. The easy way is to select the tail at the origin. But again, if we have to move along the y-axis into the negative direction, that would mean that we are stepping out of our crystal lattice. So again, we have to kind of redraw the next lattice in here. So we don't do that. Then in this case, we select a new origin, and you can see we shift the origin here with 1/2 only in the positive direction of this y-axis, because that's the only one that's have a negative sign. If it would have been, say, 1 bar 1/2 bar, then I would have to move also on the x-axis with along the with 1, if here would have been 1 bar. But as it is, it's only y-axis, so that means that we shift the origin to the 1 plus 1 to 1/2, and then we can see now, in order to that's our origin, or the tail of the vector. So and it has 0 plus 1/2 and 0. And now to find the head from this new origin, then we move, as you can see, we follow these coordinates. I'm in this origin, so we move along the x-axis with the 1. So I will be here, and then along the y-axis, I move in the negative 1/2, which means I will end up here. That's negative 1/2 from that new origin. So, and along the y direction, I will have to move with 1. So that means my head is right here. It's exactly how we draw, that we had the previous one. So that's going to be the direction which we had it in this first problem, 2, 1 bar, 2. So I hope that clarifies. Again, if all of them will be 1 bar, 1/2 bar, and 1 bar again, I have to move my origin, as you can see, along the 1 direction right here. Along the y direction, I should move it in this point, and along the z direction, I will move. So my origin will be right here. So in that case, I will stay within the cube and when I draw the vector within that crystal lattice. Here it's I propose for you to look at this understanding. I mean, test your understanding and see if you can come up with the solutions for this. If you need to give more explanation, please email me and I will answer back to you. Thank you.